quick talk to finish off the day. It's nothing that really requires any brain action on your part, so perhaps you'll be relieved after a long day of hearing about some useful things. I'm just going to have a quick talk to you about tooling. I'm someone who loves to spend time writing their editor instead of doing their job, and so I've collected a whole bunch of experiences with different tools and technologies. I think people, especially in the kernel community, tend to have adopted their workflow possibly decades ago and have kind of stuck to it. And there's been a whole world of fancy magic out there that can make our lives easier. So hopefully today you'll learn something new. Maybe not. Maybe you'll just flame me, but at least you'll have fun doing it. So let's get on into it. So what kind of stuff am I going to be going over today? The first thing is text editors, kind of the bread and butter of actually working on the kernel. We have some old ones and some new ones. We have some magic inside those editors, which includes code completion, auto compilation when you change a file, Git magic and integrations. Compilers, the main reason I put this there is to emphasize the S, because there's actually more than one now, which can compile the kernel, which is pretty cool. Debuggers, there's actually been some crazy people writing new ones of these because all the old ones suck. This includes live kernel introspection and looking at crash dumps, and some random other bits and pieces that I've tacked on the end. So first, let's talk about text editors. And when you talk about text editors, you have the big three categories. We have, of course, we have Vim, we have Emacs, and of course, Heresy. When I actually started out using Emacs because my proprietary editor didn't work on my ARM laptop, and I decided to use Evil mode, which is Vim emulation in Emacs, and I thought that meant that both Vim and Emacs people would like me and adopt me as one of their own, but it actually just meant that they both hated me for colluding with the enemy. So first, let's talk about Vim. It's going to be a very quick overview of text editors if perhaps you're new to the kernel world or development in general. Vim, you got your modal editing, so you don't have to break your pinky going to Control, Meta, Alt, Shift all the time. There's no Lisp, which is a big thing because I'm perpetually afraid of brackets. Unfortunately, it's quite dated. The code is from before a lot of common syscalls. It supports 40+ different platforms that most of you have never heard of, even the aging folk, and generally quite an abomination in there. Some people like to just press a key and have the text show up. That's kind of crazy to me, but some people don't really like that. And Lisp can actually be useful. You can turn your editor into an aeroplane if you know enough brackets. So there are certainly some benefits to having that insane configurability that you get from an editor like Emacs. Now, the problem with Vim is that it's, as I mentioned before, kind of spaghetti. I'm just going to give you some quotes from a fantastic blog post I read. I'll link it in the slides, which you can find on the LCA kernel miniconf website. So Vim is very synchronous, and that includes all its plugins. And so if you have a plugin that's doing something fancy like a code completion, for example, or a lookup of some sort, you're stuck waiting for it. The code is very spaghetti. I was going to show you some of it, but I don't really have enough time. But you can just trust me that it's quite the sight. I don't know. It's definitely not any coding style I've ever seen. Most of its if-defs and various things are for not just before common syscalls, in which you have to check for, but various things that I've certainly never used or seen before. And a few years ago, I saw a patch in 2017 that got sent to the Vim mailing list to fix something or other, and they got told, oh, don't use those evil anti-declarations because some people don't have C89 compilers in 2017. So, there are some things blocking Vim from entering the modern world, and that's the blog post I mentioned. Now, some nice folks, depending on who you ask, went and rewrote Vim into a thing called NeoVim, which is basically just the same thing. It's completely drop-in compatible, allegedly, so that includes Vim script. It's got a Lua runtime if you wanted to do fancy things with your Vim and not use Vim script. The code's nicer and neater and more modern and whatnot. They have, all these fancy new age things like CI and GitHub and Travis and unit tests and functional tests and like a UI scripting test framework thing. That makes it a lot easier to write plugins and integrations if you want to do fancier things. And I symlink it, which some people think is evil, but yeah. So if you want to learn NeoVim, let me see if this works. It's just like Vim Tutor. You just go Tutor, and it's even got this fancy inline sidebar thing so that when you do it right, look at that, we get a tick. How cool is that? That's pretty cool. So onwards to Emacs, the land of the brackets. It's configurable. It's got a really cool inbuilt package ecosystem, even straight out the box. So you can do mx package install, an email client, because lots of people actually do that. It's got all sorts of nice things you can do to it, but it's old. It's kind of crufty. Lisp is perpetually horrifying, and it's really gross out of the box. The only person I know that uses stock vanilla Emacs is Andrew, and he has the kind of judgment that leads him to host kernel mini-comps, so we don't trust what Andrew does. So Emacs has actually gotten distributions, much like Linux has distributions. So people thought, what if we make Emacs cool, hip, and pretty for the kids to convert them into the cult of Lisp? Well, some things that people have done with these Emacs distributions is that they made it look more like Vim. You have your modes and whatnot. They also usually have things that aren't Vim if you want it. They have documentation that's well formatted with things like read the docs. It's very easy to Google for to fix your problem, not just looking at decades of comments on Emacs wiki. There's a lot more pre-configured integrations with other software, so things like a lot more plug and play. So quickly going over some of these, we have Spacemacs. This is kind of the big ticket one. It's got a Vim and an Emacs mode. It's quite easy to configure. It's got these things called layers that integrate with all these other things that you might want in your editor. Why you would want some of these in your editor, I don't know, but I still see a lot of people open email in Emacs. So pretty much anything you could want inside an Emacs window, it's pretty easy to configure. It's very pretty and modern, and I know at least one subsystem maintainer that uses it, if that's an endorsement. There's also a thing called Doom Emacs, which is just edgier, basically. It's younger. The way you use it is you clone the develop branch into .emacs.d, if that scares you at all. It's faster to start up. It's got a bit less abstraction from vanilla Emacs. It has its own module system that doesn't quite have as many things in it as Spacemacs does. And I use it, which is possibly a horrific warning sign. So here's the crazy part, and this is the bit I expected to blow minds. Did you know that most developers actually don't use Vim? And here's the kicker, they don't use Emacs either. So I'm going to ask the audience, over 50% of developers in 2019 said that they use which text editor? Does anyone know? Cat, that's a good one. No Cat. Yes, I heard of VS Code, and you're right. Here we go. We're going to talk about using something with Visual Studio in the name to work on Linux. How horrific is that? That is horrifying. But VS Code is a standalone open source editor. It's from Microsoft. It has some links to Visual Studio, but it's certainly nothing like a whole IDE runtime. It is a standalone editor. It's got a built-in extension system and a nice GUI and all that kind of stuff. It has a Vim mode like everything does. You can actually embed NeoVim directly in there somehow if you need an actual Vim because you're a lunatic. It's a lot more approachable for new devs. I think if I was talking to someone who was just starting working on the kernel, this is probably where I'd lead them. It's got a lot of support and whatnot all over Stack Overflow. It is Electron-based, which means it works on all the platforms, but it also means it's gross and icky and you're running another instance of Chromium. Thankfully, we all have 32 gigabyte RAM laptops to run many Chromiums, so this probably won't affect you, but sometimes you notice. It is a keylogger, but what isn't a keylogger these days? You can turn it off. So if you use this, make sure you turn off the keylogger before your employer gets mad at you. So that's text editors. You're writing text into a file. How complex can it be? The things people ask, people say, oh, I use Vim, I use uComplete.me, I use Emacs, and I use company mode, things to let me move around my code. How do these things differ between them? And here's the kicker. They're all the same nowadays. People have realized that there's too many languages, there's too many editors, there's too many tool chains. How do we just bring this all together? What's the quality of the completions? Well, that's the thing. They're all the same. So the problem is we have an m plus n matrix of languages and editors, and we need to figure out how to tame it, which leads to the language server protocol. This is essentially a protocol that you implement how an editor speaks to it, and then you implement how it does magic for each language, and then they only have to learn that once. So this means that once you've set it up for C and taught it about the kernel, you can use the exact same key bindings, the exact same magic that you use for any Python or Rust or whatever stuff you work on, which is pretty cool. So there are two C language servers, and I'll quickly go over the way that they work. So they essentially just run in the background. They're a daemon, and your editor will reach out to them to ask, okay, the user's in Emacs and are asking for a completion on struct page. Where is that? Where are the usages of that? And then it feeds it back into the editor. So these tend to run as servers. There's two main ones. The first is CCLS and the other is clangd. So CCLS was earlier. I use it because clangd didn't work for me last time I tried it. But development's kind of slowing on CCLS. So if you want to try this stuff out, you should grab clangd. It's part of the LLVM project and should be everywhere. So how exactly do you build the kernel? The kernel has this annoying problem. Even most C projects use CMake or something, some kind of common build system. The kernel said, screw that, we're doing our own magic. Here's a kconfig. What the heck is that? So we need to be able to teach these how to build the kernel so that we can do intelligent completions, so it knows what's compiled in, so that when I work on the power architecture, when I jump to page size, I want a definition that's in Arch PowerPC. I don't want it somewhere else. How does it learn stuff like that? How does it learn what we've actually built into this thing? Well, we can generate a file called compilecommands.json, and it tells you for literally every object you build when you make your kernel exactly what flags went to the compiler and what headers were included. So these are pretty easy to generate. You can use a tool called bear. So you go bear make and it'll generate it just based on intercepting what the compiler does. Or you can run this thing in the kernel tree, scripts, gen compile commands, which will just, I don't know how it does it, but it does it and it works fine. So you can have a look at that if you want. So yeah, it handles cross-compilation. Never had to talk the thing about me compiling for PowerPC on my x86 host. It just handled that automatically. It works with both Clang and GCC. It seemed a little fancier with Clang, could do a little bit more. And you can move around the kernel pretty much the same as you can move around any other project. If you ever used a nice IDE for Java or Python or something, you go, wow, this is cool. This would never happen for C. Well, it actually does. And I'm going to try and do a demo, which, can I zoom this? There we go. So let me just quickly show some stuff. So here we are in just a random file, kernel/module.c. It's a pretty good looking file, I don't know. So I've built a PowerPC kernel on this laptop before. So if I just jump to definition on trace events.h, I can go here, and now I'm in this file, and okay, maybe I want to have a look at, I don't know, this struct trace sec. So if I look at its usages, I can press that, and now it'll tell me, okay, here's some places around the kernel where that's gotten used before. I have this kind of inline view in my Emacs, and different editors will represent this in different ways. So if I jump to that, I go to the struct. I can again, oops, what have I done? I can go look at different functions that use it. Again, if my screen size wasn't tiny, this would work much better. And now, for example, if I jump to page size, it's taken me to Arch PowerPC, because that's how I built my kernel. It's context aware. It's not just jumping based on tags. It's jumping based on how it actually built the kernel. So you get that next level of intelligence. You kind of go from grep to C tags to this. So pretty cool stuff. And again, everything I just did would work if you used a language server protocol runtime for any other language, any other kind of project. So running out of time, but I can quickly mention, if you use Emacs and you don't use Magit, whatever, Magic, Git, it's really cool, and you should definitely start using it. It'll save you a lot of time. VS Code is really good, Git Magic as well. Apparently Vim has like a Vim port of Magit, but that seems kind of terrible. I'm sure you just go out of your editor and type Git thing anyway. Compilers, Clang, it compiles the kernel. You should check that out sometime. So debuggers, quick mention of debuggers. I was at Linux Plumbers last year, and we had a debuggers BOF session. It's like, what debuggers do people use? And everyone's like, Crash. And it's like, does anyone actually like using Crash? And everyone's like, no. So there's a few guys writing new debuggers. So you ever used a debugger and been like, yes, this was easy. I bet it'd be easy to automate and script, and I still have the will to live. No one's ever done that before. So some guys wrote a scriptable debugger library, as they call it, called Dragon, and it's still in its infancy. It doesn't do everything yet. But it is pretty cool. So you can just type sudo dragon after you've built it and inspect your live running kernel. I was going to do this for you, but A, I don't have much time, and B, I thought poking at my live kernel on my laptop I'm presenting from probably wasn't the wisest decision I'd ever make. So you can do things like poke around. You can find what your init task is. You can, look at all sorts of different functions around the kernel. You can iterate for each task for different blocks. You can find all sorts of stuff, and now you have like a Python interface to do that. So there's all sorts of examples with that. Won't go into too much detail, but if you end up doing a lot of kernel debugging, whether it's live introspection or whether it's looking at crash dumps, this might be a nice way to do that, especially if you'd like to script looking for a specific thing, getting a specific metric out. This is quite easy to build around. It is quite young though. Speaking of young, SDB is like a shell-like front end for Dragon. It's even younger, and most things don't work, but there's some stuff it does know about, like stacks. It's got fancy stuff to pull stacks out with certain functions or things in them. You can look at different addresses. You can iterate through slabs and pull out things based on their allocated size and different stuff. This is very young, and it kind of only knows about things it's been specifically taught, but I'd keep an eye on this because if it gets going, you'll kind of have a bash-like shell where you can pipe different kernel debug things into each other and get a whole bunch of really powerful information out really quickly. So it's worth keeping an eye on as they keep working on it. Quick mentions of other stuff. Ccache. If you've ever built a kernel and went, wow, that took a while, and then spent another 10 minutes waiting for your kernel to build, you might want to look at Ccache. I'm sure plenty of you already use it, but it makes things very drastically faster if you're doing repeated kernel builds. Git series, I personally haven't started using this yet, but it makes it quite a lot easier to track transitions between revisions of series. If you've ever written a cover letter for v4 and go, oh crap, what did I change from v3 again? This is very good at being able to do that for you. It's one of my New Year's resolutions to start actually using this. Smart spars diff, this is just a random one I chucked in there that my friend wrote. But if you've ever ran spars and went, oh crap, there's a billion warnings, what did I actually introduce? This can give you a good before and after diff of that. I'm sure there's plenty more things, but you should let me know. So testing, this is my plug for my talk on Friday because I don't have enough time to talk about testing today, but I have a talk Friday morning about testing. It's called The Magical Fantasy Land of Linux Kernel Testing. So if you want to hear about test frameworks and stuff, you should definitely come to that and come heckle me. Yes, there it is. All right, thank you very much.
We do have a few minutes for questions, if anyone's got any.
Or opinions. I'm always down for opinions.
What about Eclipse?
Eclipse. Have in fact seen someone use Eclipse for kernel development. Have thrown up a little in my mouth. It's just, there's an editor for everyone, That's what I say. All right, thanks very much.